New year, everyone. We are in the year of 2022 and we are still doing physical sciences, specifically physics. Like I promised you in the previous video, today we will be doing the free body diagrams. So there are 3 diagrams that we'll do in grade 12. The first diagram, which is very popular, it is the free body diagram. What is a free body diagram? It's a diagram that uses a dot and arrows pointing away from the dots to show different types of forces acting on that dot there. And that dot represents an object. It doesn't matter whether the object is a phone, whether the object is a ball, whether the object is a table. You always draw a dot to represent that object, and the arrows must always point away from the dot. It must not point towards the dot. And we have another diagram there, which is the force diagram. It is not very popular, but you might draw it once in grade 12, so we will not focus more on it. What it does is that it uses the box to represent an object and uses the arrows pointing away from that box to show different types of forces acting on that object. It doesn't matter whether the object is a ball, whether the object is a car, whether the object is a house. It doesn't really matter. Always when you are doing a force diagram, draw a box, because most students spend most of the time trying to draw a car, to beautify it, to to make it look more beautiful, and they will waste a lot of time to doing that. So they decided to make students draw a box when they do a force diagram, because in the old days we were used to draw the actual object. If it is a car, we were forced to draw a car. If it was a person, we were forced to draw a person and the forces acting on that person. But for now, since the curriculum changes, we are only going to draw a box to represent any object when doing the force diagram. Another type of diagram which we will not talk about most of the time, we only use it in electrostatics when we do the force between charges, and we use that vector diagram there. There are only 3 forces acting on that on those charges. We will talk about the vector diagram in the later videos, but for now I want us to focus on the free body diagram and the force diagram. Yeah, I just want to do this with examples. I'm just gonna pick few examples and do them. Okay, at the left hand side of your screen, I believe you can see different objects being pulled by a force applied. The first one is being pulled to the right. This one is being pulled at an angle to the right. And by the way, if they say the surface is smooth, just know that there is no friction on that surface. If they say the surface is rough, just know that there is friction on that surface. Smooth, no friction. Rough, there is friction. So on the first one here, they say it's smooth, so there is no friction. There will be no force opposing the motion of this object. This object will accelerate to the left, and to the right rather. And if they say we must draw a free body diagram and force diagram of this, how will it look like? I drew it here. I hope you can see there. This is the free body diagram of this object. We have only 3 forces acting. We have the normal force, which act perpendicular to the surface. we have the weight or the force of gravity, which always acts vertically downwards, and we have the applied force, which causes this object to move to the right, like this here. But if they say draw a force diagram, you just draw a box like this here, and you indicate these forces. The normal force must not be, it must be from the surface, not the top of the object. It must be from the surface. The weight must also be at the surface, vertically downwards, and normal force vertically upwards, or 90 degrees to that surface there. And we have the force applied there on this object. Don't draw the force applied on the surface, because the force applied must be on the object. And let's move on to another free body diagram question. We have this force here. It's acting at an angle on this object there, and they told us that this is a rough surface. We have an applied force acting at an angle upwards, like that here. So how will a free body diagram for number 2 look like? And the force diagram, how will it look like? Draw it here. First of all, when you're drawing a free body diagram, you start with a dot. The first force that you might start with is the weight, because always it acts vertically downwards, like this here. And you do your normal force, which always should be equal to the weight of this object here. And we have the force applied at an angle. Some teachers might say you must put the angle here. It's also fine, but when I look at the past memorandums or the past memos, I don't see why they put angles. They just do it like this. But if your teacher say you must put an angle, then do it. And we have the frictional force, which opposes the motion of this object. If this object is going to the right, then friction is going to the left. And this is how you will get your 4 marks. And remember that the arrows are always pointing away from the dot. They always point away from the dot. And these arrows here, they must be in contact with this here, with the dot here. Don't draw a free body diagram like this here. Don't say this is your free body diagram, where you will get a 0 out of 5 for doing this. The forces must be in contact with this dot here. They must be in contact with this dot here. Even if you draw a free body diagram, a nice free body diagram like this, and you put your arrows there and there, but you don't label, they will give you a note. They will give you a 0 out of 5. And even if you draw a free body diagram like this, but you don't show arrows, you will get 1 out of 5. So make sure you always do the right things. These are the easiest 5-mark question or 4-mark question that will collect in physics. So make sure you always do the right thing. And if you have any questions, you can ask me in the comment section. I will put my WhatsApp numbers in the description of this video, and I will put my Facebook name. If you have any question concerning physics or physical science as a whole, because we have a chemistry and we have physics, so if you have questions on that, you can send me a message on one of those apps, and I will gladly reply you. We have the third object here, but this angle here is acting downwards at an angle. It is still on a rough surface. So how will the free body diagram for that look like? Of course, I drew it here. I know someone is saying this force here is acting downwards at an angle. Why don't I put this arrow here instead? Why did I put it here? They are the same thing. You can either put this S here, you can either put this force applied here and say force applied, or you can either put it here. It is the same thing. So but according to the definition of free body diagrams, the arrows must point away from the object, and yeah, even if you do the way I showed you earlier, they will not penalize you. But according to the definition, the arrows must point away from the object. So this is the free body diagram for this. So we will assume it is going to the right, like this here. And how about a force diagram? A force diagram does not change. You draw a box, you draw these forces here, and you know that your normal force is perpendicular to the surface like this, and your weight is vertically downwards. Your force applied is at an angle, and let me just draw it here. It's like this, and we have the force applied, which is perpendicular to the surface. We have the weight, we have the force applied. We can do it like this here, and we have the frictional force. We can do it like this here. We have the frictional force, the normal force, the weight, and the force applied, like this here. This is how a force diagram will look like. And this force diagram is not really famous in physics. The only famous diagram is the free body diagram, which you must always know and get easy marks on it. Now let's look at we're on number 5, I believe, and we are here on number 4. I skipped number 4, and here we are on an inclined surface. We are not on the horizontal surface, we are on the inclined surface. And how will a free body diagram of this look like if we assume that this object is going up the incline, because the force applied is up the incline? Well, it will look like this here. We will have a weight which acts vertically downwards. We have the normal force which acts perpendicular to the surface. This surface, remember, it is inclined, so 90 degrees to this surface will be like this here. It will be like this. So it is not straight like this here. If you put it straight, you will lose marks. So it's perpendicular to the surface, not the object. We'll have a frictional force which acts down the incline like this here, and we have the force applied here like this here. And how will a force diagram look like? You will draw a box that is at incline. You will do your weight here, which acts vertically downwards. Weight. You do your force normal, which is perpendicular to the surface. You do your applied force, like this here. What did I do? It must be like this here. And you do your, this is force applied, and you do your frictional force there. Frictional force. Remember, a frictional force must be in contact with this object here. Let me do it nicely so that you do not get confused. Let me do it like this here. You have your frictional force there, and this is how you will draw a free body diagram for this object here if it is moving up the incline. Let's look at number 5. This force applied here is at an angle, at a certain angle which we don't know it. And let's look here. A free body diagram for this will look like this. We always have the weight acting vertically downwards. It always acts vertically downwards. It does not change. Vertically downwards, whether incline or horizontal, vertically downwards. And we have the normal force perpendicular to the surface, 90 degrees to the surface. We have the frictional force always parallel to the surface. We have this force applied here at an angle. So we have this force applied here. I think I lost my pen. We have this force applied here, like that. And this is how a free body diagram look like. You can draw your own force diagram, because you just draw a box and you follow the same steps here. And then let's look at number 6. How is number 6 different? We have this force here applied at a downward angle here. So how will a free body diagram look like? It will look like this here. Like this here, we have a weight acting vertically downwards, and these arrows are connected to that dot here. We have the normal force, which is perpendicular to the surface. We have a frictional force which opposes the motion of the motion of this object here. We have since this force is downwards, we kind of assume that this object is moving up the incline. But if it was the other way around, we will assume that it is moving down the incline. And we have this applied force here. It came at an angle, at a downward angle here, and we put it here. If you like, you can put it here also. But remember that the definition says the arrows must point away from the dot. But if you do it like this, you won't be penalized. You will be given your full marks. And yeah, let's move on. We still have 4 more to go, and we will be done with free body diagrams. I know it's a lot. Let's look at the left hand side of the screen. We have 2 objects being pulled to the right by a force applied. Let me move my chair. We have 2 objects here being pulled to the right by a constant force here of Fa. Now let's talk about the tension here, because this is where you get your full 5 marks. What does this tension here do on this object? Does it speed it up or slow it down? Of course, it will cause this object to move to the right. Why? It is being pulled. It is being pulled by this object here, and it will cause it to speed to the right. But what does the tension do on this object here? Does it speed it up or slow it down? Of course, it is slowing it down. It does not speed it up. And yeah, it means that the tension on this object will be going there, and the tension on this object will be going there, because it slows down this object, and it speeds up this object here. And yeah, that is it about tension. And yeah, let's do the free body diagram. We do the free body diagrams separately. They might, in a test or in an exam, they might ask you to draw they will ask you to draw one of these. It's either you're going to draw a free body diagram for this or for this object here. So now let's look at M1, this object here. And what are the forces acting on this object? We have a normal force, which is vertically, which is perpendicular to the surface. We have a weight, which is vertically downwards, and we have the frictional force. They told us that this is a rough surface, so there is a frictional force here, and we have the tension, which causes this object M1 to move to the right. So there are only 4 forces acting here. But let's look at M2 here. We have the normal force, which is perpendicular to the surface. The weight, remember that anything that has mass has weight. Things like charges, since they don't have mass, you cannot say they have weight. They do have mass, but their mass is very, very much less, so they are almost weightless. But we'll talk about that later. You might be wondering why in some free body diagrams you don't have weight. It's because of weightlessness, but we'll talk about it. And we have the force applied, which causes this object to move to the right. We have the tension, which slows down the speed of this object, and we have the friction, which opposes this the motion of this object. Remember that friction does not allow two surfaces to slide across each other. if this surface going there and this surface going there, then the friction disallows this type of sliding here. And if you rub your heads together for a very long time, you will feel the heat there, and this heat is because of the friction. And yeah, that's it about friction. If you want to learn more about friction, you can, there are so many books talking about friction and so on and so on. But what you have to know about friction is that it always opposes the motion of an object. That's it about the friction. What about this object here? What will the free body diagram for this object be like? Of course, it will be like this here. For M1, it will be like this. We have normal force, we have the weight, we have the frictional force which opposes the motion, we have the tension force which allows this object to move to the, remember that this force applied does not act on this object, it is only acting on this body here. And free body diagram for this, we have the normal force, which it is vertically upwards or perpendicular to the surface. We have the weight, we have the force applied at an angle here. The force applied at an angle in grade 12, we will have to break it down into its components. We will do it in later videos there. And yeah, we have the frictional force which opposes the motion. We have the tension here which slows down this the speed of this object here. And what do we have here? We have this system here. What will a free body diagram for this system look like? Of course, for M1, for this mass here, we have four forces. We have the normal force perpendicular to the surface, the weight vertically downwards, the frictional force opposing the motion. We have the tension at an angle. I told you that the tension can be at an angle. There are only three forces, as I told you in the first video, that will be at an angle. It is the force applied, the tension, and the weight. They can be at an angle. Only these three forces here. And the free body diagram for this mass here, we have the applied force at a downward angle here. The free body diagram for this will be like this here. We have the force applied pointing away from the dot. We have the normal force, the weight, the friction, and the tension at an angle. Remember that the tension here goes upwards, the tension here goes downwards. That's why the tension on one object is positive, the tension on the other object is negative. And I hope you are familiar with this here. And these lessons here will be beneficial to grade 11 learners as well. Do show them this, they will learn a lot from this year. Now, what will a free body diagram for this look like? They can either ask you to draw a free body diagram for this object or for this object here. So a free body diagram for this mass here will have a normal force perpendicular to the surface. Remember that this surface is inclined, so perpendicular to the surface. We have a weight vertically downwards. We have a frictional force which opposes the motion. Because the force applied is going to the right, we will assume that this system here is going to the right. So frictional force will go to the left there. And a free body diagram for this will look like this here. We have the dot, we have the force applied, we have the normal force perpendicular to the surface, we will have a weight, a frictional force, and a tension. This is how you get your 5 marks here. You get 1 mark for normal force, 1 mark for force applied, and 1 mark for weight, 1 mark for friction, 1 mark for tension. So you get your 5 marks there. And the only way you can lose marks in free body diagrams is if you add an additional force. If you add air resistance here, you will take 4 out of 5 or 3 out of 5, depending on the mood of the examiner. And if your arrows here don't have I mean, if your lines here don't have arrows, you will take 1 out of 5 or 4 out of 5 depending on the examiner. And if your arrows here do not make contact with the body here, then you lose marks. So make sure you always do the right things and do not lose unnecessary marks. And this is it for this video. In the next video we will talk about the inclined the formulas first, and then we do the inclined surfaces and the horizontal surfaces. So I will see you in the next video.